All right. Circle conjecture number 4. Circle conjecture number 4. If an inscribed angle intercepts a semicircle. So what we're going to do is we're going to draw the picture first because I think you guys already know this answer. So I'm going to draw the line across. What is this called, this line? Diameter. That's a diameter. Okay. I'm going to make an inscribed angle so that the angle touches the edges of the diameter. So there's my angle. It touches the edges of the diameter. So if I trace this, my inscribed angle has an intercepted arc that is a semicircle, because a semicircle is another way of saying half of the circle. So if an inscribed angle intercepts a semicircle, or has an arc that's half the circle, then what is the measure of the angle? 90 degrees. Okay. Then it forms a right angle. Then it forms a right angle. All right, go ahead and turn the page. We're going to do some example problems. So we have to solve for 5x. Let me go ahead and trace this angle. And how big is the arc? 180. It's half of the circle. That means the arc is 180 degrees. And so that means 5x is 90 degrees because that's half of 180. And so now we have an equation to solve. We're going to say 90 equals 5x. So what do we need to do? Divide by 5. $18. Anybody else need to trade a cell phone and get a calculator? All right. Now, sometimes we're going to run into problems where we don't really know how to get to the answer super easily. And in that case, I just start to label everything that I can figure out. I just do everything because that makes it a little easier. So I'm going to start off with that angle that I can see that is probably 90 degrees because that's what we're practicing right now. So I'm going to start off with this. So the blue arc that I drew is half the circle. So how many degrees is it? The arc itself is 180. What's the angle? 90. Okay, there's my 90 degree angle. All right, so that's part of it that I've labeled. Now I'm going to go ahead and take the 52 degree angle next. So here's my 52 degree angle. I'm going to trace it out. That's my 52 degree angle, and here's the arc that goes with that. So if the angle's 52, then what's the arc? If the angle's 52, what's the arc? 104, because it's double. The arc is always double the angle. Mm-hmm.
Can we just add all the angles together and then double the angle, the mystery angle?
We have a few different ways to get to x, right? So we know that a triangle adds up to how many degrees? 180. So doing the triangle and finding the little angle that's left could be beneficial because the little angle that's left goes with the arc that's labeled as x. That's one option. The other option is we can look at the whole circle, right? And how many degrees are in a full circle? 360. So we could say this arc and this arc and this little arc that is left, those have to add up to a full circle. So if we do 360, take away 180, take away 104, what do we get? 76. And so the arc that's left over is 76.
what I did is I added 52 and 90 together and I subtracted that from 180, got 38, doubled 38, and that's 96.
So you took the triangle route, and that's fine. All right, so x is 76. When we get to these problems, there's usually multiple ways to solve them.
If this were on a test, would you care which way we did it?
No. And if this were on a test, you drawing the angles, like me seeing the marker on there, me seeing the 104 labeled, me seeing the 180 labeled, that would all be partial credit. So when I grade this, it'd be like a 4-point problem or something. The final answer would be one of the points, but I'd probably give a point for you figuring out that this arc was 104. I'd probably give you a point for knowing that right angle and that 180. So those would all of that work that you show would be your partial credit in case you couldn't solve the problem. So any part that you could draw accurately, I'd give you credit for, even if you didn't finish it. Okay. All right, circle conjecture number 5. If a quadrilateral is inscribed in a circle. So what is a quadrilateral? Quad. 4-sided shape. What does it mean when it's inscribed in a circle? It's inside of it. It's inside of it so that all the corners of the quadrilateral, all the vertices of the quadrilateral touch the circle, all right? It doesn't have to be a square, but a square is an example of a quadrilateral. It doesn't have to be a rectangle, but a rectangle is an example of a quadrilateral. I'm going to go ahead and draw just a funky one. You can draw whatever shape you want. It just has to have 4 sides. So here's my quadrilateral. I'm going to draw it like this. Okay. Yeah, it kind of is. Well, trapezoids have 2 sides that are parallel, and none of mine are quite parallel.
Wait, but it looks kind of like a parallelogram because the 2 sides.
Yeah. All right, so here's one angle, and then here's going to be the angle that's opposite of it, right here. I'm going to go ahead and show you what this is going to do, okay? So if I take the blue angle and I trace it out, just going to follow that blue angle out. Here's the arc that goes with the blue angle. Everyone see that? That's the arc that goes with the blue angle. And then I'm going to go ahead and take my orange and trace that angle out as well. So here's my orange angle. Here's the arc that goes with the orange angle. So what happened with my arcs? How much of the circle did my arcs take up? All of it. So the blue arc and the orange arc added to 360 degrees. So that means the blue angle and the orange angle added to... So the arcs added to 360. So the angles add to 180. What's a word for when things add to 180? Starts with an S.
Oh, I remember this.
Starts with an SU. Supplementary, okay? So if a quadrilateral is inscribed in a circle, then its opposite angles So when I did the blue and the orange, they were considered opposite angles because they were across from each other. Then its opposite angles are supplementary. Okay, and the reason that we can see that is because when you trace them out, their arcs make a whole circle. A whole circle is 360, and so the angles would be half of that. The angles would be 180. Okay, measure of angle HIF is 92. So I'm going to trace out HIF. HIF is this one right here. That angle is 92. Okay. They want IFG. I'm going to skip that one for now. They want GHI. I'm going to skip that one for now. FGH. So if they want F to G to H, that's this one. Okay, so if we have that HIF is 92 and FGH is what we want, then what do we know about them? They're opposite angles, so what should they add up to? 180. So we're going to say 180 minus 92 is 88. Okay, so this one is 88 degrees. Okay, I'm going to go ahead and erase this because I can. Wow, it's like magic. Don't try to erase yours. You're probably going to rip a hole in your paper. Okay, so then the next one says GHI. So from G to H to I is this one. They want us to find, let me go ahead and write this. This one was 88. GHI is what we need to find, but they did tell us that IFG was 84. All right, so what do we need to do with this one? 180 minus 84 is 96, and so the other one is a 96-degree angle. Okay. What should all four of those angles add up to? 360, because any four-sided shape has 360 degrees total. O is the center of the circle. They typically have a center point, and that's what they call them, so this would be called circle O. Yeah. All right. Circle conjecture number 6. If an angle is formed by a tangent, anyone remember what a tangent is? You might have to look at the front page of your notes. What's a tangent?
That's the one that just kind of goes like a radius. It's like it just goes straight through, connects at 2 points, but it keeps like going.
No. Look at the front page of your notes. It's labeled on there.
Like 1 point of tangent where it meets.
Yeah, a tangent line is always outside the circle, and it only touches 1 point on the circle, and the 1 point that it touches is called the point of tangency. All right, so tangent line is on the outside of the circle. It touches in one spot. Okay, so what we're going to do is we have 2 example pictures for this one, and we're going to draw the tangent line twice. So I'm going to go ahead and say, here's my tangent line. I'm going to draw it about the same way twice. Tangent line, tangent line. Okay, everyone got their tangent lines drawn? That means this right here, that's the point of tangency. That's where the tangent line touches the circle in exactly one place. And what we're going to do from that is we're going to draw a chord. What's a chord? It's a line that goes in a circle. A diameter is an example of a chord. All right, and then this is the angle that we're talking about. Okay, so when we have this drawn, even though it looks different, this is still considered to be like an inscribed angle, kind of, but the relationship is the same. So if an angle is formed by a tangent and a chord, then the measure of the angle is half of the measure of the intercepted arc. The measure of the angle is half the measure of the intercepted arc. And there's actually 2 different ways this could be drawn. So if this is the arc, we would call the arc x degrees. And then the little angle inside would be 1/2 of that. Or you could look at the other side, and say this is the arc and call that x degrees. And then I drew the angle on the wrong side. My bad. My eraser's terrible. Okay, and then this is the angle that would be half. So the picture looks different, but what we're learning from it is the same, is that if the angle's on the edge of a circle, then it's half of the arc. Okay? If the angle's on the edge of the circle, then it's half of the arc. Okay, go ahead and flip the page. We're going to do this example problem. All right, so this is one, there's a few things labeled in the picture. Things are getting complicated. What I like to do is I just start labeling every single thing I can find, okay? So I see this 35 degrees. I'm probably going to deal with that first, okay? So I'm going to start with my marker. Okay, so if that is a 35-degree angle, then what's the arc that I just drew? 70. Okay. Anyone see something else we could do? You see a 90-degree angle in there? Okay. So, and I'm guessing it's this one. This is the one you're seeing? Okay, so if we follow this out, okay, so is this half the circle? Is it? Yes. You can see, do you guys see the little dot right there? It's very small. Do you guys see the little dot?
Oh my goodness.
Yeah, that right there is the center of the circle. It's kind of hard to see. It's very, very, very small. But that means that this line that goes through it is a diameter, which means that this really is half the circle. That's 180. And so that means that, that Jason was right. This angle right up here is a 90-degree angle. Okay? What else can we find? It doesn't have to be an answer. It doesn't have to be X or Y, but is there anything else we can label in the picture? Huh?
Q to J.
From Q to J, that arc, we can find the length of that arc, right? How are we going to find, or not the length, but the degree measure? How can we find? Okay, so we're going to say 180 minus 70, and that's because if we cover up this purple part, then this is half the circle. So 180 minus 70 is what? 110, okay? That arc right there is 110. Okay, so Jason thinks that y is 55. Do we agree or disagree? We agree? Why do we agree? Yeah, because he's right. Okay, so if we trace it, here's the arc, right? There's the 110-degree arc. If I trace it down here, we can see that that arc goes with angle y. And so that means angle y is half of the arc, and half of 110 is 55. So we just solved one of the things we needed. Okay. And now we need to find angle x. And you can see that angle x is on the edge of the circle, so that means it's going to be half of the arc that it goes with. We just have to figure out what arc is the arc that it goes with. Okay, so I'm going to take angle x, I'm going to trace it out. I'm going to use yellow this time. So I'm tracing this out, I'm tracing this out. There's angle x. So what is the arc that goes with angle x? There is an arc that goes with it. This is one of the tangent line ones. So one side of the angle is a tangent, the other side is a chord. And if I trace this, that's the arc right there. So what's... Say it again? Wait, where's K? Oh, out here. We don't know the measure of K. We haven't learned that yet. X would be 35. So if you look, here's our tangent line. Here's our chord. The arc that it has is 70. And so x is going to be half of the arc. That means x is 35. We're going to stop there with the notes for today.
Thank you.
You're welcome. All right.